Hey guys, so welcome to 1.6. We are classifying polygons today. So there are a few vocab words that I want to go over, and I do not have enough space on that sheet of 1.6 notes. So again, if you want to write it on the back of that front cover page of your packet, or at the end of your vocab, wherever it fits, okay? But please do not try to write it on the 1.6 page. So first of all, before we really get into this, we need to know what is a polygon. All right, and a polygon is a closed figure. Made of 3 or more segments. All right, and it's important that it's segments. So remember segments are line segments. They are straight, okay? They have an end point and a beginning point. So they are not curved. So if it has any type of curve, it is not a polygon. All right. Now, we have, so we could have convex polygons and something that's called concave, and we'll go over that in a minute. But a convex is when no line that contains a side contains a point on the interior. All right, so what this basically means is if I have a shape, and let me use my lines here, okay? So something like this. All right, if I were to draw a line through any of my sides, like this one, it goes through the interior of my shape right here. So this is a concave, not a convex, okay? And let me put those direct examples in. So these, anything that has sides like this, where none of your sides have a point inside this shape, that is convex. All right, so concave, think of it caved in. So concave, example, I'll draw my little diagram again. Here we go. It's caved in. Okay, and that's different than the first one, but it is still concaved. Caved in. All right, let me clear this. So the other three things I want to go over are equilateral, equiangular, and regular. So equilateral. So you guys probably have heard of this word when we talk about triangles. And an equilateral triangle is a triangle where all sides are congruent. Okay, so an equilateral polygon, same thing. All sides are congruent. I'm going to use my shorthand here. All right, equiangular, take a guess. All right, it's where all angles are equal, are congruent. Okay, so if that is true for a polygon, it is equiangular and an equilateral, then it is called a regular polygon. So this is when both, let me rewrite that. A regular polygon is if the polygon is both equiangular and equilateral. okay? All right, so let's start on this note page. All right, so our interior angle sum, and this is kind of just cool knowledge, all right? You can find the interior, the sum of all your interior angles by the number of triangles that can be drawn within the polygon, okay? So we're going to look at the table below. So a triangle, right, is something with 3 sides. It's a polygon with 3 sides. Inside a triangle, there is 1 triangle. All right, now we will get into this more, but when you have 1 triangle, your sum of all your angles is 180 degrees. For a quadrilateral means you have 4 sides. All right. I can split my quadrilateral into 2 triangles technically, so there would be 360 degrees inside. All right. My pentagon, penta means 5, so there are 5 sides. We could technically split this into 3, so there are 540 degrees inside. All right, I am more concerned about you guys remembering the number of sides and the name. All right, do not worry so much about this yet. All right, so let me keep going. Hexagon, heka, means 6. All right, so it has 6 sides. And that means it can be split into 4 triangles, and that means that it's 720 degrees on the interior angles. Hepta means 7. All right, I do not have a diagram for these, but it has 7 sides, so it could be split into 5 triangles. It has 900 degrees on its interior angles. Octa, think like a octopus, it has 8 tentacles, 8 sides. All right, we could split into 6 triangles, and we have 1,080 degrees. Nonagon, like 9, has 9 sides. 7 triangles are inside of it, and oops. All right, and we have 1,260 degrees. All right, deca means 10, so we have 10 sides. There could be 8 triangles inside, and that would be 1,440 degrees. All right, so again, we're looking at the names. I want you guys to remember the names and their number of sides. All right, all these diagrams on this page are regular polygons because they are equilateral and equiangular. All right. We can always find the sum of our interior angles. If n represents the number of sides of a polygon, then the sum of the interior angles could be found by using this formula. So our interior angles is equal to our number of sides minus 2 times 180. Okay, and that's because each triangle has 180, and if you notice, the correlation between the number of sides and the number of triangles inside is always 2 less than the number of sides. We can also find then, if it's a regular polygon, we can always find the angle of one of those interior angles. So a regular polygon is one in which all sides are equal, and therefore all angles are equal. So to find the measure of the interior angle in a regular polygon, we use our sum of our interior angles, and we divide it by the number of sides. Okay. And that gives us the measure of our interior angle. Oops, I forgot interior. All right, and that's it for today. We will Zoom in a little bit. See you then.